I need someone to understand, who's patient when I'm in my head. 'Cause all these thoughts got me too damn scared. Still I fall.
You good? All right, good morning, everybody. Yeah, good morning. Hey. It's Saturday morning. I hope you had a chance to take in some Saturday morning cartoons up in KPMG stage, and thanks for joining us this morning. Of course, it's Saturday at 9:30, so you should be sleeping in, and so really appreciate having you all here. We're going to do a couple of things to kick off this morning. First things that we're going to do, so just drop everything that's in your hands or put it down, because we're going to do a little bit of exercise. We need to wake up a tiny bit probably. The coffee probably helped. And so what we're going to all do is we're just going to stand up for a second. We'll just give everyone a second to do that. All right. So yesterday we talked about what you wanted to learn at DevFest, and we're one day in, and we still have a lot of content left. Who was here yesterday? Okay, hands down. Who wasn't here yesterday? Just a couple people. Glad to have you today. Thanks for coming. For those who were here yesterday, I want you to turn to someone close to you that you don't know, introduce yourselves, and share what you learned from yesterday that you might take back to your company or organization. And for those of you who are just here today, I would like you to turn to the person next to you and share something that you want to learn today from DevFest. And we'll give everyone just 2 minutes to do this. All right, everyone should be transitioning to their second person. If you haven't shared the second person, go ahead and do that now. Okay, folks, I think that we're about there for this little segment. And we'll just take our seats again. Glad that you got some exercise this morning. All right, yeah, if you're at the top, come on down. Come all the way down, and we'll get you seated at the front. Don't feel shy. Okay, so I'm glad that everyone had a chance to do that. Get up and move a tiny bit. We're not going to do any yoga this morning because I'm not terribly good at that. But I hope you all learned something yesterday, and if you have something to learn today, really looking forward to that. I personally appreciated a number of the talks yesterday, Naramani Hanuni, yesterday was just a great, fun talk. The people that were there learned a little bit about the Palm API and how to use that. So, what's the date today? Can someone yell out the date? 18th, okay. Does anyone have a birthday today? Okay. Does anyone have a birthday tomorrow? Hands up if you have a birthday tomorrow. Did I miss someone? 19th, anyone birthday on the 19th? Okay. Fortunately, I think I know who this is going to go to. Who has a birthday yesterday? Sherry, put your hand up. Sorry about that. So we'll give you a Google backpack. Happy birthday. I'm trying to think of one other thing. So we'll go to just run through a couple of things here this morning. So let's go to the next slide, if that's okay. Oh, sorry, Kris Reed. We're not quite there. I'm going to introduce Kris Reed in a second. We had some slides about community and about sharing your photos. So if you get your phone out, we'll see if we can get that slide up just to make sure that everyone has a chance to share photos into the photo gallery. Otherwise, we'll send the link to you today, and so we'll get going with that. Yeah, let's see if we can get it there. We might be there. Okay. We'll leave it, no problem. So anyways, I'm really, really pleased this morning to, we'll go back to Kris Reed's introduction. Sorry, guys. Sorry about that. I have a different, there we go. Share photos, that's it. So take your phone out, and just grab a picture of the QR code. And then everyone has probably taken photos of the event, and I do want you all to share them into the album. So the album's collaborative, and you are able to share them in and see photos from other attendees. We'll definitely do a contest on that for some of our favorite photos and give out some of our swag after the festival's over. So that's one thing. The second thing, let's move to the next slide, I think. I just wanted to make sure everyone is also aware of the fact that we have Google Cloud Skills Boost. So if you got your ticket in the last 24 hours, we'll have to do a little bit of finagling to get that sorted out. But if you got it 48 hours ago or more, everyone has access to Google Cloud Skills Boost. And the reason why that's important is because you may be here to learn. And if you're here to learn, then why not certify your learnings and certify your expertise in these areas. And so with Google Cloud Skills Boost, you get access to, I think it's 35 different learning tracks and up to 700 different learning activities. And so everyone, as part of the festival, has access to that for 2 months. You can do as many of the learning tracks, as many of the activities as you like. And when you get done an activity, you can share the certificate of the activity onto your LinkedIn to let people know that you've completed, something on how to, for instance, use the Palm API. And so this is a great opportunity for everybody to continue to advance the learning that they have, especially good for people who are new at some of these cloud themes or some of these security themes or AI themes. So that's good. So I just want to make sure everyone knows about that. And that is happening in East Hall. So if you need a hand getting set up or you want to sit down and do a lab today, just go to East Hall, which is the same room as the registration, and they'll get you going today. So, and then we'll also send that link out after the fact. So again, that goes for 2 months. Everyone that has their email in will have 2 months of access there. It's usually a subscription service, which is why it's valuable for everybody. So I am very, very pleased to introduce Kris Reed. He's the co-founder and CTO of Neo Financial. And the reason why Neo Financial is such a great and incredible story, number one, born here in Calgary. So that's one amazing thing. Number two, they're here to disrupt financial services. And if you are a technical person, you understand how complex financial services are. You recognize how difficult it is to do something that's easily scalable, incredibly flexible, and allows your customers or allows you to deliver new value to your customers very, very quickly in a way that, again, is faster than the other banks and faster than the other financial services around. So super, super happy to have Kris. I had a preview of this talk in the last couple of days, and I'm very, very excited to welcome to the stage to talk about the secrets of reliable, scalable microservice architecture. And I hope you all enjoy. Welcome, Kris.
Hey, everybody. My name is Kris. Nice to meet everyone here. Thanks for having me here. I am from Neo Financial, and today's talk is going to be about some secrets for microservice architecture. Already got a great introduction from Greg. But what he didn't tell you is that even though I'm co-founder at Neo, in my heart, I'm a software developer. Who in the audience is a software developer? Yeah. So I'm somebody who's written code my entire life. I still can write code. People ask me, have you forgotten how to do that now that you have a company? No, I'm still a software developer. How many of you in the audience work at a company founded by or owned by someone who's a software developer? Not that many, actually. Not that many. And I think that's pretty cool part of Neo too. And not to toot my own horn too much, but having a tech focus for the entire company, rather than kind of having a tech team at the company, is something that we're really proud of at Neo. And okay, I love making you guys put up your hands. It's a real power trip. Who's heard of Neo before? Oh wow, that is so cool to see. This month is it's my 5-year anniversary at Neo. I met my co-founders about 5 years ago in November. And in fact, we started the company here at this library. So we used to rent a room upstairs, one of the little meeting rooms, and we would get together, just kind of sit around a table and work on starting the business, planning the business, coming up with ideas, figuring out what we needed to do. This was really our home right here in this very building 5 years ago. Who has a Neo card? Oh, that's pretty good too, but there's a lot of you who need to get the Neo card out there as well. So it's not hard to do. You can get it in like 30 seconds in an app. We are trying to build the future of banking. We're trying to build a challenger bank, a digital bank here in Canada that can take on those big 5 legacy banks. Everybody knows who they are, right? It's your parents' banks. Let's build something that's actually better. And that's what we're all about at Neo. Neo is a tech company. I've heard people even say, oh, you guys have this plastic card, is that really a tech company? What you don't know, maybe, is that the entire tech stack that runs all of our banking and financial products is completely in-house at Neo. And we've actually built one of, if not the most sophisticated banking platform in the world here in Calgary at Neo. Yeah, that's amazing, right? And it's pretty amazing. It's something that no other financial institution has. At Neo, we do our own credit card processing, for example. What that is every time you use your card, let's say you tap it to buy a Starbucks, right? We get a message in real time, and we have a real-time processing engine that we coded and built that actually checks your balance and checks if that transaction is legit and checks if it could be fraud and actually decides, should we give you your Starbucks or not? And that actually happens here at Neo. We built that engine. We're the only financial institution that has that. And so these are like tremendous technology advantages that we actually have at Neo that are propelling us forward. But I'm not going to talk more about Neo. I want to talk about microservices. And I'm not going to waste a ton of time explaining what microservices are. Who does not know what microservices are in 2023? Don't be embarrassed. One person. Well, you're not going to get to hear it from me today because there's only one person in the audience who doesn't know. The overall idea of microservices in 10 seconds is that on the left, you have this monolith architecture. Usually you build some software and it connects to a database, right? On the right, more of a microservice architecture, you build many different computer programs. And each of those computer programs maybe has its own data store, and they all work together to actually create the experience. And Neo has this microservice architecture. I think we're one of the companies leading the way on microservice architecture. So why? Why not just do it the old-fashioned way? Why not just build a giant app and then just deploy it? And a few key reasons I wanted to share. Autonomy is something that I think is really, really important. If you're on a team of like 50 software developers, you don't have that much of a voice, right? As a dev on that team, it's like, even if you do have a vote or something, you put your hand up for something, you're one of 50 people. And when you have these giant software systems, what I find is like everybody gets more and more disempowered as it gets harder and harder to change and update and pivot that software. With microservices, an amazing thing is there's almost like a social side to it. Each of these little services is usually owned by different people and different teams, and you have different champions for different things within the company. And they actually have more autonomy and a bigger voice, right? And people who take ownership over the code they write make awesome code. Hopefully that's how everybody feels about coding. And so when you're in a microservices company and in a microservices architecture, you get that higher level of ownership. You also get to be really fast and fearless. So when a program is very small and very simple, you can just check it out of Git, read it through, pretty much understand everything it does really fast. Make a change, run some unit tests, be pretty sure that the unit tests tested your code properly, and then just ship it. You can do that really quickly with very little fear. Whereas bigger, complicated systems, you might run half an hour of tests and then still kind of feel queasy about the idea of deploying to production. So you get to be way faster and more fearless. And then fail better and scale better are two reasons to use microservices. Fail better because if one of your services goes down and then maybe comes back up, people might not even notice. Whereas if you have one giant system and the whole system crashes, right? The process exits or something like that, it's just toast, right? So you have this way higher level of resiliency with microservices, and then they can also scale independently. And at Neo, we have about 150 services. And we can scale each of those services up and down. We can build a cluster of 10, or scale it down to 1 if we want, right? And that allows us to actually handle traffic, but also manage costs and all kinds of things way better. And then the last thing I have up here is, use microservices because you want to skill up your team. And this was important when we started Neo. It's this thinking that we're not just at the company to just kind of write code. We're not like coding robots. We're trying to build a product. And building a product is going to have all kinds of integrations over time. You're going to have to connect to other companies, other software, other modules. You're going to have to buy stuff. Your company might acquire another company and have to integrate their stuff. You're going to not just be in this bubble forever, right? It's more of an ecosystem. And so when you actually start with microservices, you're kind of living in an ecosystem from day one. You're sort of having a mentality and a skill set on your team where deploying something new that you've never deployed before, integrating it and testing it is part of your DNA at your company, and that's really powerful. But there is some hate out there about microservices. Two people, I've got quoted up here. Who knows who DHH is? He's a real jerk. Nobody knows him? Okay, well, don't go looking him up. He's the guy who, I think, invented Ruby on Rails. That's his claim to fame. And, he tweets. So there you go. And I think one of these quotes is even, from Martin Fowler, who's a pretty famous computer scientist. And, some of the things people say are, if you can't handle one code base well, what makes you think you can handle 100 code bases well? And a lot of teams, they do have technical debt. They do have maybe like a lack of automated testing, even with one code base. So are you just complicating your life? I think, again, DHH also said, hey, are you Netflix? Do you have 1,000 devs? If not, this is maybe overkill for you. And I love this last quote, if you use microservices, you're just replacing modules of your code with higher latency modules. Because with microservices, the code is living across a network, and you have to make network requests instead of maybe just calling a class or calling a function. So it sounds like a bunch of negative things, and there are common problems with microservices. Companies often jump in, start building some microservices, and then they're like, oh, this isn't going so well. They're underestimating some things like maybe the DevOps requirements of running 150 services or even running 10 services. And at Neo, I mentioned, again, maybe 150-ish services. We run over 1,000 containers. And we process something like 175 million queue messages a week. So like the DevOps requirements to keep that going are actually pretty tough. And there's this overhead with microservices setting up the cloud, setting up DevOps. And of course, like cloud providers like Google and Amazon are making it easier and easier, but it's still kind of hard to set up all of these cloud resources that you're going to need. I think companies also find that coupled services are worse than no services. And what I mean by that is like somebody will complain. When one service fails, all my services are failing. Right? As soon as one fails, the whole thing just crashes. You know whose fault that is? It's kind of their fault. They've built a lot of coupling into the services, right? They haven't actually built them in isolation. Last couple things, I think that make microservices problematic. It could just be the wrong fit for your culture. At Neo, we have like a really agile culture. And the way we think about maybe risk is if it hurts, do it more. Have you heard that phrase before? Right? It's like, because if you do it more, you're going to get better at it, and it's going to hurt less. Some companies have a if it hurts, stop doing it approach. And so depending on your company culture and your philosophy, microservices might be a good fit or might be a bad fit. And then I love this, teams go mad with power when it comes to microservices. They're like, today we're writing our services in Rust. No, tomorrow we're writing our services in Go. That team's going to write their services in Swift. That team, and everything just kind of like goes out of control at some microservices companies. And it's tempting. It's really tempting because when you're running maybe a whole bunch of different services, you can just pick up a new programming language and use it. But that's going to come at a cost, and oftentimes it's going to frustrate teams and cause problems down the road. Ultimately, there are pros and cons to microservices, and I'm not going to use this whole talk to sell you on them. I think it's a pretty amazing architecture, but it really comes down to a bit of a personal choice. Look, if you have a great team and good leadership and you do the research, you're going to make any architecture work. Like really, any architecture can work. It comes down to the team and how well you do it. But at Neo, it was really sort of a personal decision. And actually, I'm gonna point to a guy in the audience. Wave, Ian. Wave. Ian was the first developer to join Neo, which was amazing. Yeah, and we had to sit down and just say, what do we believe? What do we believe in? What is the best developer experience? What would that be like? What do I think makes code maintainable? Forget about what it says in a book or what I read from somebody on Twitter. What is the best development process? What is the dev culture that we want to have at our company? And so microservices at Neo came out of like a philosophy of like rapid change, being easy to deploy, continuous delivery, and things like that. Okay, so that's kind of the intro to the pros and cons of microservices. But what I really want to do up here, and I got 20, 30 minutes to do it, is give you all some of the secrets to doing it really well. And if you decide to go away and use a microservices architecture, does anybody have a microservice architecture now with lots of different services? A handful of people. Don't raise your hand if you're from Neo, that's cheating. Yeah, so maybe you can take away some tips to doing things really, really well. And this is something we've perfected at Neo over the last 4 or 5 years. First thing, that is very important is service design. And there's 2 rules to service design, Too small of a service, you'll go crazy. Too big of a service, you'll go crazy. So it's kind of tricky. There's like a sweet spot for how big your service code bases can get. And I think I have a few more slides on this. And also how you split the services up, right? And this is like something you need to put a lot of thought into. I like this quote from Robert Martin, Uncle Bob. I think he's still alive. He's a pretty old guy. He's one of the people who signed the Agile Manifesto, and that long time ago. And he says, gather together things that change for the same reasons, separate those things that change for different reasons. It's like a very samurai quote or something like that. But this is how you need to think about separating out your code. If you're going to be making a change, you want that change to only have to impact one code base, not both code bases when you're deciding on a split of the code. You need to create a domain. There's a great book, Domain-Driven Design. I'm sure many of you have heard about it. And then around the domain, there's like a boundary, right? It's like how you decide where the ends of the services are. What's What is that decision point? And when I talked about being too small, some teams, they start building services for every single noun. It's like, oh, we have a user, that has to be a service. We have it's a bookstore app. We have a book, that's a service. We have an author, that's a service. We have everything is a service. And that's too small. You're going to go crazy. You're going to have way too many services, and each service is going to be so narrowly scoped that it won't be able to really add value on its own. So you don't want to go down to like every table or every data model having its own service, but at the same time, it's tempting to get bigger and bigger and bigger, and pretty soon you have a monolith, and you start having all of the disadvantages of a monolith and the disadvantages of a microservice architecture, and that's not going to help you at all. So a domain is a logical area, defines the kind of problem you want to solve. I like these examples. Something like purchasing is a good domain. That might have multiple objects, multiple data tables involved in purchasing. It's an activity that involves different things. Maybe there's prices, maybe there's inventory. Inventory could also be something. There could be items in your inventory, but there could be other aspects of inventory as well. Second tip, other than just making sure your services are the right size, is not being chatty. And this diagram up here. This is a microservice architecture diagram from one of Neo's competitors, one of the leading digital banks in the world, a company called Monzo in the UK. And they're a very tech-forward microservices bank. I think they might be one of like 3 other banks trying to do this cloud-based microservices approach. And this is their service diagram. They have something like 2,000 services, and it is a ball of spaghetti. I don't want to hate on them, but if I had to look at this diagram every day for my job, I would go home every day with a headache. And you start getting to a point where it looks like every service kind of talks to every other service. It gets impossible to really untangle what's going on. And when somebody is using the app or something, and a request goes to the back end, it just kind of spins out across this whole environment, and something could go wrong over here, and tracking it down is going to take forever in this kind of situation. So at Neo, we've taken a really opposite approach to this, and we've said, don't be chatty. So at Neo, we try not to have services call other services really at all. Again, that's very different from this Monzo diagram. And this sort of approach, you would kind of have an RPC, remote procedure call approach. You almost treat every service like a function in your app, and you can just call that function anytime. But not so at Neo. I'm going to tell you guys how we achieve a very not chatty environment with about 150 services in it. The first trick that has worked for us is something called federated architecture. And the way federated architecture works is when your API calls come into your environment from your web app or your mobile app or your device, they come into a gateway. And the gateway plays 2 functions. It can be a distributor or an aggregator, right? And the role of the gateway when it's being a distributor, that's for inbound requests. It distributes to the other services. So it kind of says, hey, to fulfill this request, I'm going to need to send a message to 3 services. And then it splits your message and sends it to 3 places to start processing and doing the work. And then what happens is those services do their work. Each of them might play a part. And then they send their messages back. And then that's when the aggregator comes in and it says, OK, I got information from these different services. Sometimes it could be as simple as just, OK, I finished. But that's information, right? So it aggregates that information. OK, service 1 finished, service 2 finished, service 3 returned some data, a block of data. Great, I'm going to make that into my response, and I'm going to send it back. So this federated architecture depends on a gateway to be distributing and aggregating. And when you have this kind of gateway architecture, you don't have to have as much service-to-service communication. Imagine this slide did not have the gateway. The API request might come in, go to our, say, reward service here, And then the reward service might say, well, I need to know this user's identity. And then it would have to talk to maybe an identity service. So you'd start getting the service-to-service calls if you didn't have that idea of, hey, let's try and make these services work independently. The second thing that's really important that enables these services to work more independently is a service should already know everything it needs to know. So when a request comes in, it doesn't need to go asking for information. It knows how to solve its problem. And we really try and follow that approach at Neo. Replication really helps. And so this is kind of a cheesy replication diagram. But if you start over on this side, you can see there's an event. Bam, an event happens. State has changed. There's some business event. OK, well, we publish that event, right, to a message bus. And there's a stream of these events happening. And other services can subscribe if they're interested. So I'll give you an example. Let's say every time anyone at Neo changes their email address, we publish a message. An email address has changed. We blast it out. And services that are interested in email changes can subscribe. And then when that email change happens, if this other service needs to know about it, it consumes it. And it says, OK, great. What's the new email address? And then it might take that email address and actually store it in its own models. And we're not talking about copying like the entire database table. What usually happens is it's just maybe a select field. And so the source of truth for email addresses might be somewhere there's a table, just for email addresses. But email address might also be a field on another object somewhere, on a message or on an account or something like that. And so you actually do end up with replicated data. But guess what? It's 2023 and data is cheap. Storing data is really cheap. You don't have to, it's not like the Y2K problem anymore where they only had 2 digits to store dates, right? We have the ability to replicate data almost for free. So that's something we make heavy use of at Neo. And then you get a situation where, again, services know what they need to know to do the thing they need to do. And you don't end up with that really chatty architecture. And this is kind of a good segue into my third tip, which is being very event-driven. If you're going to go down a microservices path, I think trying to do everything synchronously is really a recipe for a headache. The more asynchronous flows you can have, the better. And so sometimes at Neo, maybe you do something in the app, an API message goes to the back end, and then on the back end, we're just like, cool, we'll handle it. And then the front end is kind of like gets the response back. It's in progress. And then asynchronously, we're maybe doing things in the background. Services are chugging away, data is moving around, and then when it's completed, right, we can change the state again, publish a new message, send a message back to the client, and be like, hey, this state has changed. It's now finished. The processing is finished. And sometimes those asynchronous operations can happen really quick. Sometimes they can take a long time. You might do something that takes 30 seconds or a minute or something like that. And that's actually OK if you design those sort of asynchronous operations. And we do this at Neo all the time. A lot of our code is event-driven. We use queue messages to make sure that it's robust. We can do things like retry a message from a queue if processing fails. Or if a service even goes down and comes back up, we can continue processing right where we left off in this sort of environment, right? So asynchronous architecture has a lot of advantages. I think most people know this, but when you're building any kind of service-oriented architecture, there's something called a share-nothing approach. You really want to follow a share-nothing approach if you care about things like isolation, if you want to have low coupling of your services. If we had 2 services that shared a database at Neo, then we would have all kinds of problems. One, concurrency issues. What if one service is trying to change a record, the other service is also trying to change the record, right? Which one wins? What if one service is using one format for a string, another service uses a very slightly different format for the string because the code is different? Then you start introducing problems, and you get way more coupling between services. OK, I need to make a schema change to my database. Now I have 2 services that somehow need to simultaneously be deployed with updates to take that into account. Again, that kind of stuff will really degrade your scalability and your speed, create single points of failure. So at Neo, we have this shared nothing approach. Every service gets its own database. So we run hundreds of databases. Again, databases are cheap though. Again, Google Cloud, Amazon, all these providers, they give you access to scalable storage at an incredible price, so why not leverage it? Being careful about common code is something I think at Neo we learned the hard way. We started building services at Neo, and then at some point we're like, it seems like we're writing some of the same code in all of these services. There's kind of some common code that we would need. So we're like, great, we'll put it in a library so it's reusable instead of copy-pasting it between all these services. So pretty soon we have a bunch of libraries for things. And then every service includes a handful of libraries. Great, well we don't have copy-pasted code anymore. Every time someone updates one of those libraries, 100 services need to be deployed. That is not good. That's very hard to manage. So then you need to start thinking about, okay, is a common library really what we want to do here? Because you're going to have hundreds of services. They're going to have different versions of the library. Or again, it's going to be a real pain to get them all updated to compatible versions. And you start having compatibility issues. You have to make a breaking change to the library. What happens in production? It's a real heartache. And so you need to look at other patterns. There's things like a helper service. So build a service that kind of fulfills that function instead of maybe a library. That's possible. Or we actually started grouping our libraries. So we have something called Neo Framework, which is really just a whole bunch of libraries. But now instead of having to manage all this huge group of libraries, we just say, well, what version of Neo Framework is this service on? Oh, it's on version 2. Any other service that's on version 2 is allowed to call it. If it's on version 3, it's backwards compatible to 2, but it's not compatible with 1, for example. So it just simplifies the problem down. But this is a real tricky thing in the microservices world. And then this is my last architecture tip for you guys, designing to fail. It doesn't do you any good to say, hey, we're going to have this robust system of microservices, and if one fails, everything will be cool, and then it doesn't. It doesn't work that way. One service fails and everything fails, or you're in a bad state. So you kind of need to build with some patterns in mind around what if a service does fail, and a service is going to sometimes fail. So there's something called a bulkhead pattern, and bulkheads are used in like ships, right? If the ship gets a hole in it because it hits like the Titanic, it hits an iceberg. Well, the bulkhead's supposed to be closed. So when the water comes in, it stops the water, and the ship doesn't sink, right? So you can build bulkheads with a microservices architecture. You can split some services off over here, and then other services off over here. And then maybe put them on separate networks. Have some more isolation between groups of your services. And then you can say, even if a cascade failure starts happening, one service fails, then another service can't do its processing, and it starts to fail. Well, even if a group of them fails, there's like this sort of isolation, there's this bulkhead, and not everything crashes. This works really well in Neo because we have different products. We have credit cards in Neo. We have bank accounts in Neo. We have mortgages in Neo. So if mortgages is down, credit cards should not be down, right? So we have all these services, but we've actually tried to build them into almost like silos with bulkheads in between. And then there's something called a circuit breaker pattern. Hopefully some people are familiar with circuit breaker. In the world of electrical engineering, I guess, circuit breakers interrupt the circuit. They turn off the circuit when there's too much current. And that's something you can build into your services and apps. If you get too many requests happening, too much traffic, switch off the requests. And this is really helpful because otherwise you do get sort of like, imagine a hose and you squeeze the hose. Well, then it starts to build up pressure, back pressure, behind where you've tightened the hose. And pretty soon that back pressure is going to get stronger and stronger. And then when you release, it all has to flow through, and it'll like explode everywhere, I guess. So that can happen with requests. If you have a service or a queue that's not processing, you start building up a backlog of things to do. And then if you fix a problem or a bug, that backlog has to get processed through. Circuit breaker makes sure that those backlogs are manageable. So you need to kind of design with some of these patterns in mind whenever you're passing messages or consuming from a queue to make sure that if there's an outage, you don't kind of go splat. And then the last thing I want to chat about, I'm more or less on time here, is DevOps. I kind of touched on this earlier about how a lot of companies underestimate the need for DevOps if you're going to go down a microservices approach. And I'll say it right now, you're going to need a dedicated team, even with just a few services. At some companies, not every company has a dedicated infrastructure team or a dedicated DevOps team. But I think once you start building services, you're probably going to need it. And it's an output of some of the things I already talked about. Who's going to manage scalable clusters? Who's going to manage costs of all these services running in production? Who's going to manage a different database for every service and running dozens and dozens of databases? And then optimizing and tracking and monitoring. Who's going to handle problems like logging? And so you need, in this environment where you make those things more complicated, you're going to need some experts on your team who are really trying to make that great. And at Neo, we're really lucky. We spun up our infra team almost on probably day 2. I think one of our first 3 or 4 people we hired was someone who said, hey, I'm going to just jump in and be the infrastructure person, make sure that we have fast and automated deploys so that when someone wants to deploy a service, it's just like that. We use configuration as code. Again, very important. We use Terraform at Neo. But if you don't do that and you're just drag and dropping things in the cloud through a GUI front end, it kind of defeats the purpose of having all of these different services, because what you really want is to almost be able to template out, right, how each service works so that you can repeat that process. When someone needs a new service, no problem. We just take this template, we stamp a new one, away you go, new service. But if it's very manual or inconsistent, then people start saying, oh, I don't want to make a new service. That's a real pain in the butt. So I'm going to just kludge this code into one of our existing services. No one will ever know. It'll be easier for everybody. And then what happens is your services get weird and big, and the domain gets all fuzzy. So you need to actually make the friction for new services go way down. And things like distributed tracing or centralized logging become big problems really quickly. In distributed tracing, there are great cloud-based tools for it. Again, tracking a request that goes across a couple different services. Even in Neo's case, where we do asynchronous processing with queues, you can actually say, okay, this service created this queue message got picked up over here later, and then it got run, it got processed, and then a request went over here. We can actually track that whole flow and optimize it and check its performance and look for errors or warnings or things like that. And you have to start asking yourself about mass changes. What if there's a configuration change? How easy is it going to be to make a configuration change to 100 services or even 20 services? Is somebody going to have to go and manually update 20 places in the code and do 20 deploys? Or are they going to have to, or is there some maybe quick, sneaky way? Maybe your configuration is all external to your services. You can just make the change in one place and all the services pick it up. So those are the kinds of DevOps problems that your team will need to solve. Okay, this is, I think, maybe one of my last slides, but I want to kind of wrap this up and talk a bit about, again, about what this has meant for our team at Neo. It's one of the best decisions we've ever made at Neo to build microservices. It has created tremendously good uptime. We can do 5 nines of uptime at Neo. That's really hard. And our competitors in the banking space, they shut their systems down at night for maintenance. If you try and log into some of the big bank portals at 2 in the morning in Canada, it'll just say no. That's not 5 nines of uptime. So we have incredibly good uptime at Neo, incredible speed. We deploy to production over 800 times a week. That's how many production deploys we do at Neo. So that's like an absolute insane pace. That's in an 8-hour day, that means in 100 deploys an hour. No, wait, it's across the week, right? So it'd be a fifth of that. Let's say 20 deploys an hour. It's still a lot of deploys in an hour, right? It's every minute or two, somebody's saying, I'm deploying to production now. We've been able to scale our team. And I talked about autonomy and ownership over these services and code bases. And we have something like 350 GitHub repos. That has allowed us to scale the team and the people really well. Over 175 devs at Neo and 20 different software development teams. And it's actually gone pretty well. And that's not an easy thing to do, to scale your team up to 200 people in just a couple of years. We have pretty happy devs, a really good local dev experience. Does anybody work somewhere where if you want to run the code locally, you need like 32 gigs of memory and it takes like an hour to build the software? Come on, admit it. It's got to be somebody. OK, a couple of people. You never get to that point with an architecture like this. You can just check out a couple services. Our services will run on like 500 megs of RAM. So you check out a whole bunch of them. Run them locally on Docker containers. It's super easy and super quick. And running tests only takes minutes instead of hours. We have really cool tech at Neo, and that's one cool thing about a distributed architecture like this. If we want to start having services that are cloud functions, we can do that. If we want to have services that are maybe off-the-shelf software that we get out of a marketplace, we can do that. And so it lets us bring in more cool tech. We've brought in a lot of cool tech at Neo. When every service has its own database and data store, you can also eventually start customizing what kind of data store is best for this service. So we use a few different databases at Neo. We have NoSQL databases when NoSQL makes sense. We have immutable databases when immutable databases make sense. We could use a time series database when time series makes sense, and have a SQL database when we need SQL database functions. And we can actually make those decisions a lot quicker and easier in this environment. Our QA is very easy at Neo. It's, again, small service, very easy to automatically test it, and even manually test it if we want to. We have great team mobility in this sort of approach, and team mobility is something that I used to underestimate the power of. It's like everyone at Neo uses the same programming language, but that's not enough for somebody to say, get up out of their chair, walk across the room, go to another team, sit down and start coding. It's not just about the programming language, right? There's a lot of other stuff to learn when you change teams. They might have their own conventions, and then the new code base, again, it can be intimidating. Even though you know the language, you might be scared to make that first pull request or that first deploy. And we don't really have that at Neo. Again, small services, they're quick to learn, quick to read, easy to test, easy to comprehend. And there's a lot of ownership. So when you go over to that new team, there'll be an expert who maybe owns that GitHub repo who'll maybe actually help you learn it really fast and get going really fast. So that gives our devs a lot of mobility in Neo. People can change teams, and people do. People are on different teams every 3 months sometimes, and you get a lot of variety and get to work on different products in different parts of the business. And success makes everybody happy, and I think we've been very successful with our tech architecture at Neo. Sometimes when we're hiring and interviewing, people will ask me, they'll say, Kris, what's the biggest tech problem at Neo that I'm going to get to come and solve? And I try and think, do we have a really bad tech problem at Neo? Sometimes the problems we have are more like we're growing really fast and we don't know everybody's names and we need to do more social stuff together. I think about those kinds of problems much more than I worry about things like downtime or outages or people being on call. Those things are really well solved at, in this architecture. And it could be for your team as well. OK, so that's it for microservices. I hope that some of you have learned something you didn't know before about microservices, or maybe you're interested in learning more. There's some great books out there on microservice architecture, microservice design, or things like domain-driven design. I recommend picking one up. Neo is hiring. We're hiring software developers. We're hiring all different levels. We're also hiring product managers, UI designers, and lots of other roles if anybody's interested. And then I think there's a little bit of time, maybe 5 minutes for questions here. So I think what we're going to do is there's a microphone down here. So if you want to ask me a question, you got to race down the stairs, don't trip, and stand in front of the mic and ask a question. Anybody have any questions? Oh, somebody's coming. No pressure, though. Don't trip.
Kris.
Hi.
It was a fantastic talk.
Thank you.
I would say, nobody would deny that fact. Like, yeah, great. So did you ever, like in the initial stage, right, you're setting a strong foundation when you're going to microservices. It's not that easy because you're doing a monolithic architecture. You see results real quick, right? Did you have a lot of convincing to do? Like,
Sorry, did we have a lot of...
Did you have a lot of convincing to do in the beginning that,
Yeah.
hey, it's going to take 3 months to really see some product like an MVP?
That's a good question because you're right. It's like you put in a little more effort at the beginning and you don't see a return. Like 2 services, for example, is not that much better for the business than 1 service. Nobody's like, oh, thank goodness we have 2 services. So there's some skepticism, and you're putting in all this work trying to set up a queue so you can message between the services and trying to figure out how to scale 2 clusters, and you have to run 2 load balancers. And everybody's like, why are we doing this? Why are we running 2 load balancers, not just 1 load balancer? So you do have some resistance at the very start, but there are some things that I think have made it way easier. And one is that the public clouds are so good. And if I'd started Neo 10 years ago, I don't think it would have been a good idea to build microservices. But now it's like you can actually start your second service as a cloud function. It could just be like a Lambda or something like that, right? So there's not a lot of overhead in just throwing some code into a cloud function. And if you use things like configuration as code, and again, we adopted Terraform, your developers can literally just have another window open in their IDE and just throw some Terraform in there, and then when they run the deploy, it just like terraforms out the cloud infrastructure for you, right? So, and you're maybe even just copy pasting. So the effort of like, well, we're setting up a server or we're setting up a database is no longer like costing the company tens of thousands of dollars. It's just like, no, we're going to just paste 3 lines of Terraform in here, and we're done. So I think as long as you're taking those approaches of like empowering your devs, using those sort of like rapid tools, you can get going with services a lot easier. But it does help to have buy-in, and it's something that I was really passionate about from the culture side. Again, I think that really helped Neo get behind our architecture. There's this sense of like, even when we were 5 devs, everybody could have their own GitHub repo to own. And then you really feel like an owner. You're like, this is mine. It's my baby. I'm going to make sure it runs well. I'm going to keep the code clean. I'm going to keep the tests good. And you feel like so much ownership when you actually have something that's yours. And we could really start doing that even with really small teams, as long as we had small services, right? Rather than it being like, I'm the co-founder, I own the code, and devs don't really feel like it's theirs. They just do what I'm saying, and that's not the culture we wanted to have. Hope that answers your question.
Yeah, it does. A follow-up question, right? So
there's nobody else in line, so.
Good. I'll keep you engaged then. Okay, so it felt like you have so many best practices, and you made right decisions at the beginning, right? So as your team grows, is there like a Neo manifesto sort of thing that your developers have to go through, or like how do you make sure that these best practices live on?
Those are the kinds of problems I worry about. Again, when I was saying before, do we have tech problems, tech debt and things? Not so much. I do worry about, do we do enough? And I don't think there's one answer there. There's some tribal knowledge, right? So when someone comes into the team, it's like, who knows about, how do I find out about this? Everybody just knows, so talk with somebody. And it's that tribal knowledge that you learn. And that's not the best, to be honest. It doesn't scale super well. Pretty soon you have to start thinking about codifying your tribal knowledge into some documentation, right? And we have a wiki that we use that does have some of our best practices in it. Okay. And I'd say a good tactic is always having a few maybe services or some parts of your code that you can say, this is the example. Right? So when someone joins the team or they're new and they're like, how should I do this? You can say, well, this is the example to follow. And we have many other services, classes, code bases, GitHub repos, but this one is the state of the art And it's usually the last one we built, because every one you build is a little better than the one you built before. So this last one we built is really good. And then, okay, you can kind of go look at it and read the README on GitHub and check out the code, and you kind of learn that way. So it's a combination. But at Neo, we have gone through hiring blitzes because we've needed to scale the company. And so there was a month where we hired 31 senior devs in 31 days. And that was pretty tough because you have 30 people starting at your company. And that's like half this audience. And they're all like, what do we do? And you have to have a plan there, right? And you have to train those people and show them the ropes. And so we do start to build more of almost like a classroom approach. It's like, well, okay, come to the classroom. We'll have a bunch of our best devs come into the classroom and give a little talk and do internal sessions. And we do a lot of that at Neo too, trying to scale up the learning, the way that classrooms work. And we do that in our onboarding processes. Even today, most days when somebody starts at Neo, they're in a cohort of 10 or 20 people who've started at the company. So it's like a group of friends all starting together, not just a person starting on their own. Great questions, though. Thank you. I think we're about at time. What do you think, Greg?
Let's do, we know that there's other sessions starting right now. If everyone that's going to those other sessions just wants to take 2 minutes and go, we'll take another 5 minutes after everyone sort of makes a quick transition. So yeah, we'll just give you a space to go do that, and then we'll take a few more questions up till about maybe 5 minutes after we get back.
And I just want to say thanks to everybody as you're leaving.
Yeah.
Thanks for listening to me.
Yeah.
And thank you to all the volunteers, the hardworking people on the cameras, the mics, running the slide stuff. There's a laser show. So yeah, amazing job here.
Yeah,
thanks,
thank you,
everyone.
Kris. Yeah.
Hello.
Hi.
Yeah, so I had a question about, I guess, data consistency, right?
Sure.
Because I was thinking about your diagram with, every service has their own database, right? And even, like you said, different database architectures. And yeah, I guess I'm just stuck on, let's use the user as an example, right?
Yeah.
So your user's got an email address that's changed, but the user might be a common property or object between services. So how do you deal with that?
Yeah, it's a good question. So we sort of classify operations, usually at the API level, right? We'll say, is this an operation that can be eventually consistent or an operation that needs to be maybe transactionally consistent? You can implement a distributed transaction pattern, like a Saga pattern, across microservices. So you can essentially have an actual sort of transaction happen where it's just like having a database transaction, right? So there's sort of cases, they're actually pretty rare, when we need to maybe implement a distributed transaction to keep consistency down to the transaction by transaction level. But actually a lot of things can just be sort of eventually consistent. And that's actually okay. It's very rare that there are real race conditions in the world. Where, for example, if you're using the Neo app, right? It's not like you have two phones and you're using both phones to access your account at the same time. You're kind of on one phone, you know what I mean? So all your requests are happening in a sequence, and it's unlikely that if there's a data propagation to another service that's delayed, that you're going to have another request against that service that needs that maybe very latest information in real time. And we also have caching and things like that, like a write-through cache. So sometimes what will happen is data will get written to a write-through cache. Then it eventually goes and gets consistent in the database, but the cache is actually already up to date. So the next request that comes in hits the cache, it gets the cached value, which is easier to get. So basically what I'm saying is that is an issue, and there's a bunch of different patterns to try and solve it. But it's not as big an issue as, again, people think. Most of the time, eventual consistency is sort of a good pattern for you to follow, yeah. Anyway, I hope that answers the question. Yeah. There are cases when it's not, though. So yeah. Anything else? No?
No, that's everything.
Cool, thanks. Thanks for the question.
Hey, you bet, yeah.
Hey, I have two quick questions. So the first one is you said that you put in the queue the processes,
Yeah.
that are connected. So the first question is, what will be if in the middle process will happen something bad,
Mm-hmm.
What else? What should we see? Or how the microservices will work in that case?
Yeah, so let me kind of phrase the question back to you. We maybe have a message on a queue, and there's a service, its job is to process messages from that queue, right? So it's a consumer. And what happens if that service was to fail? So the way our queues work at Neo is the message is either not sort of popped off the queue until processing is complete, right? So in that case, if something is half finished and the process fails, you could restart the process. That process would go back, look at the queue. The message is actually still there. So it would start processing it again. And there is a worry in that case of, well, what if you have duplicate processing? You accidentally process twice. But our transactions or our operations at Neo are idempotent. So we try and basically make sure that if you process the same transaction twice, you are not creating a duplicate. And I won't go into explaining idempotent transactions, but like it's sort of like you can never have a duplicate by processing the same message twice. So that kind of pattern means that even if there's a breakage, you can resume. We also do have dead letter queues at in some cases at Neo. So what happens is a message, maybe there's a bad message on the queue, and it's kind of like it's like blocking the queue, kind of, right? Nothing can get popped off the queue because that message just sucks. I don't know how it got on there, but it goes into a dead letter queue, right? And then that dead letter queue probably has alerting, on it, and then some like sort of alert goes off. Like the dead letter queue is getting bad messages, and somebody has to actually, like a dev probably has to deal with it. That's kind of more of like a worst case bug scenario than like a normal thing, but that's also something that can come up. So I hope that answers your question. You had a second question?
Yeah. And the second question is like you said that you gather your code like in the libraries,
Yeah.
And just to manage it, you make like the chain. And how this approach like help you to manage the code? Because it's like the chain into the chain into the chain, and what is the approach?
Yeah, I think maybe I touched on it a bit before, but definitely that sort of problem of having libraries where you group code into, pretty soon it's like, okay, changing that library, again, changes lots of different code bases and you need to update them all. Even that library might be used by another library. And then another library might use that library. And then that library might be used in 100 services. So updating libraries becomes a real problem. And again, there's no like perfect answer. Groups of libraries, into like a kind of a master library makes sense. It means that you can do fewer kind of bigger library updates.
So in that case, you like have a lot of libraries, as far as I understand, just to manage little smaller libraries.
Smaller things, yeah. So an example, if you know maybe Node.js, like Express is like a common kind of like library, but Express actually is a bunch of things. They have a router library, they have a middleware library, and there's a bunch of libraries that are part of that one kind of master library, right? And when you include the master library, it goes and gets a bunch of dependencies. So you can kind of group them like that to just make it like okay, we'll upgrade this one thing. And then we have like, a good versioning scheme as well. You have your major version, your minor version. If it's a minor version update, it has to be backwards compatible. If it's a major version update, it could be a breaking change. And then you need to be very cautious about that. Try and make more minor version updates to your libraries so that you really don't actually have to roll them out in one big bang, because it's backwards compatible. You can just sort of slowly adopt new versions of the libraries. And then once in a while, if there is a real need for a breaking change, then you do need to coordinate something big. And ultimately, there are times at Neo when we have to get in like a Slack channel, and somebody's like, I'm going to upgrade this library with a non-breaking change. Everybody's going to need to adopt it. We get every service owner in that channel, and we're all doing it on Friday, and we do some like big service upgrade. That happens. You want to minimize. You don't want to be doing that every day because it's annoying and distracting. But there are definitely times when we do a concerted push to get like a breaking change deployed out to a bunch of services or something like that. Yeah. So hopefully that answers your question.
Yeah.
Just one?
Yeah.
Looks like Neo is going in a really fast pace. How do you manage your microservices when it's going really big? Like, do you use something like Istio or
It's a good question. Yeah, we're actually adopting service mesh right now. Although it doesn't really speed up, I would say, how well you can build microservices. I actually think service mesh is not something you need on day one. The biggest value of something like Istio is it's like a control plane that lets you manage things like traffic and security, things like that. And I think you need it at scale. You need it at scale. So we're adopting that kind of. There's a bunch of different service meshes depending on your like programming language and runtime. But yeah, that's somewhere we're going, is to start using that kind of tooling. But it's not really necessary. I think, back to my picture of like the ball of mud microservices. If you're building this kind of architecture where there's tons of communication complexity, okay, maybe this company really gets tons of value out of using a service mesh approach and having more sophisticated like network management. But if you think about maybe our federated architecture, where it's more flat architecture, then it's not as important. And we can just kind of add new services to the sort of graph that we expose, and by just adding kind of a node or a leaf to the graph, and then federate that into our gateway, and we can do it pretty quickly. So hope that's an okay answer, but yeah, it's case by case as well. It's case by case. Yeah, you're welcome.
Can I still ask
Go ahead.
one more question?
Yeah.
So I'm a DevOps, and do you have any advice to a team that just starts on their journey in microservices? Also, if they already have an existing like giant monolith.
Yeah, I didn't really talk about that. I thought about it, how to migrate from a monolith approach to maybe a microservice approach. Some of these critical success factors apply. If you haven't adopted configuration as code, you should do that first. I would say it's very important. Even for your monolith, you can still terraform your resources or use something like another competitor, CloudFormation if you're on Amazon or something like that. So I would do that. Again, I would implement logging and tracing. Make sure monitoring, logging, and tracing are good in your environment before you even start, right? And then I would start small. So maybe consider adopting like a cloud function, Lambdas or Kubeflow or whatever the Kubernetes one is. But I can't remember anyone know the name? Okay, well, yeah, one of the cloud function sort of approaches, that might be a good way to get started and start moving some of your new logic into cloud functions. For us, like the easiest services to spin out are usually things like batch processing or nightly jobs. Those things, put them in services. That's easy because it just runs once a night at midnight, like you can stand alone, right? So there's sort of easy cases where you can just put those things into their own functions or services, start there. And then I guess the last thing I'll say is there's a pretty well-documented pattern called the strangler pattern or strangler approach for taking a monolith and breaking it up into services. And a lot of big companies with even really legacy systems, like from like the 60s and stuff, COBOL systems, they followed sort of the strangler approach to modernizing code. Not just for microservices, even for things like rewrites. Like let's say you have some COBOL code and you don't want to write COBOL because you can't write COBOL anymore. And you want to do it in C#. Well, rather than rewriting the whole thing, you kind of want to rewrite it piece by piece. And each piece you want to check if it works, maybe deploy it to prod, and you're sort of slowly strangling the old system by replacing it with a new system. So that's kind of how Strangler works. It's been proven. It's worked, companies nationwide. You can do the exact same thing to start sort of strangling off pieces of your monolith. But again, don't just do it for the sake of doing it. Really think about, is this company, I think I go back to one of these slides, is this company the right company for microservices, right? So if you work somewhere and they love their monolith, don't try and make them do microservices. If the team really doesn't want to be distributed into many small teams. If that's not how the people want to work, then you can't make them adopt microservices. It's kind of like the people have to come first, and then the service design follows. Many small teams of people, microservices works great. One giant team of people with like centralized management might not be a great team to have microservices. So I'd consider some of the company culture, the company structure, who you have on your team and stuff like that, and then make a decision. Hope that helps.
It makes so much sense.
I think a lot of companies that have big, especially legacy monoliths, they probably shouldn't go to microservices, or they shouldn't rush into it. Cool. Do you have another question? Or?
Thank you.
No problem. And last one, we'll say last one. Okay.
Well, I have a couple of questions.
Well, last one though.
All right. You have a lot of services.
Yes.
And what are infrastructure costs for all the services?
Infrastructure costs are pretty high. I'm not at liberty to say, but like, let's just say Amazon. We're on Amazon, not Google, even though this is props to Google. But they like us a lot. At Amazon. They give us free engineering time and access to beta services and all kinds of other stuff because of our size. So we're pretty big. We're pretty big footprint. Yeah. But look, at the end of the day, it's like I don't think so much about the total bill. It's more like what's the bill per thing, and the bill per thing is really small. Like some of these services, they run for dollars, pennies. We're running them on maybe. Containers with 256 megs of RAM or 512 megs of RAM and 1/8 of a CPU unit or something. So if the services are really small like that, and then you run a little cluster of them, it's very cheap, very, very cheap. And I think all the major clouds now, like they offer those like super low tier, super low cost kind of modular container or service models, and like that's what we do. We run thousands of services, but these aren't like massive machines with 100 CPU units or gigs of memory. They're really small, so it's not that expensive from that perspective.
All right.
Yeah, actually, we use Datadog for logs, and the Datadog costs are almost as high as the AWS costs. So that's a whole different issue. Hopefully, nobody from Datadog watches this video.
Get a lot.
Cool. Okay, thanks, Greg.
Thank you, Kris.
Yeah.
Round of applause. This was excellent.
I'll stick around up at the top. If anybody wants to chat, you can come by and see me.
Yeah.
Maybe Ian will stick around with me too, one of the devs from Neo.
Yeah, we have a couple of folks from Neo, I think, going to be in the expert zone this afternoon, so make sure to swing by there and say hi to them. And again, thanks so much.
Thank
really
you.
Appreciate it.
See everyone later.
I know folks are transitioning in. You're looking for Chelsea Tate's talk on unlocking career growth with Google Cloud certificates. Unfortunately, Chelsea actually can't make it this morning, and so we're going to probably see if we can reschedule her. So keep an eye on the schedule online. It'll be updated as soon as we have a new slot for her. So we're going to actually see Michelle Brenner, who's in the crowd here sitting waiting from Netflix. And she will get started at the top of the hour. So if you'd like to stick around for that, we'd love to have you. And even better, this gives everyone a chance to get up and get some more exercise and come down to the front. That would be fantastic. Michelle would love to see your lovely faces, I'm sure. Always makes it easy. And we're just really, really happy to have Michelle here. Michelle has been all over the world this summer and for the past couple of years speaking. She is definitely a world-renowned developer speaker. And so we're just really grateful to have her here. So please stick around for that at the top of the hour. Thank you.